Okay, so I have this trig identity right here. I see that my left side is more complicated, my right side's a bit simpler, so I'm just gonna simplify this first really quick. I'm gonna convert these two to 1 over cos and 1 over sine. I'm gonna squeeze it in the side over here. So I have 1 plus 1 over cos x sine x. And then I'm just gonna make a common denominator for this so that it looks a bit simpler. So I'm going to multiply cos x sine x on the top there. So I have cos x sine x plus 1, my common denominator of cos x sine x. Now that looks fully simplified. I have a nice common denominator. Everything's coses and sines. I'm going to start by working on this side over here and try to reach the same thing over there. So when I look at this side, I kind of have two options to get to that. Number one is I can try and make a common denominator because there's a common denominator on this side. So if I want to do that, I have to multiply the top and bottom here by 1 minus cot x and the top and bottom here by 1 minus tan x. I actually tried that and it doesn't work because the bottom doesn't get simplified and it's really hard to get the bottom into that. So that step didn't work, which means my other option is converting everything to sine and cos. So tan x is sine x over cos x, and cot x is cos x over sine x. Same thing over here, that's cos x over sine x over 1 minus sine x over cos x. Okay, now my next step is just to make a common denominator on the bottoms. So top stays the same, sine x over cos x. The bottom is now sine x minus cos x over sine x. So made my common denominator there. And I'm going to do the same for this bottom. So cos x over sine x over cos x minus sine x over cos x. Okay, now that I have a fraction over a fraction, they're perfect fractions. I'm going to change this divide into a divide sign. So I have sine x over cos x divided by the bottom. So sine x minus cos x over sine x. And I'm going to do the same for this one. So plus cos x over sine x divided by cos x minus sine x over cos x. I'm going to flip these two divides to multiplies and flip those two fractions. And then I'm going to just write them with the common denominator. So this sine x is sine square x over cos x sine x minus cos x plus, oops, I forgot to flip this one, cos x minus sine x. Forgot to flip that, so flipped it here. So that becomes cos square x over sine x cos x minus sine x. Now if we compare these two denominators, these two brackets are almost the same, but this is sine x minus cos x and this is cos x minus sine x. So if I want to make them identical, I just have to factor out a negative and I'll make them identical. So I have sine square x minus cos square x. So I change the sign to a minus. I'm going to flip that around. Okay, and now we just do a common denominator. These two are the same, which means I have to multiply sine x on the top and bottom here and cos x on the top and bottom over here. So I'm going to get sine cube x minus cos cube x, and now I have a common denominator of sine x, cos x, sine x minus cos x. Now if you look at the top over here, that's just difference of cubes. If you don't know what difference of cubes is, it's basically similar to difference of squares. So I'll show you difference of squares really quick. If I have a square minus b square, that's a minus b, a plus b. If I have a cubed minus b cubed, that's difference of cubes. It's a minus b, a square plus ab plus b square. So we're going to use this equation, difference of cubes, to continue the top over there. Okay, so I have sine cube minus cos cube, so I'm going to turn that into sine x minus cos x, sine square x plus sine x cos x plus cos square x. Okay, so basically that top turns into this top, and then the bottom is just the same, sine x cos x, sine x minus cos x. Now in this step, these two brackets are identical, so they can cancel off, and sine square x plus cos square x is just 1. So on the top I have sine x cos x plus 1, and the bottom is just sine x cos x. If you compare this, it's identical to what we had on the other side right there.